All right, looks like it's only you for now. So I'm gonna get started. People may come in, but this shouldn't take long. It's not that difficult. So let's go into it. So we're gonna talk about logarithms. Now it sounds difficult, sounds like it's something that's hard to do, but it's not. All logarithm means is exponent. Okay? It's a different way to look at exponential equations because, for example, if you come here at the top, exponential form, if I have a base b and I have the variable x in the exponent and it equals some other number, let's call that a, right? It's hard to solve for that equation because we need to get that x out of the exponent, right? We want to solve for x, but it's stuck in that exponent. So another way we write this is we call the exponent a log, and we write it in this form. So we have log, which is short for logarithm, and it has a little base, little number or letter down there. And it has a number next to it. That's what we're finding the log of, and it equals x. And if you notice, it matches the exponential form. The base of the exponent right here is b. The base of the log is b. The exponent is x. That's what the log equals to. The log equals to x because log just means exponent. So the log equals the exponent. And then what we're taking the log of, a, is what this whole exponential equals to. So if you look here, I know it got a little messy. If you look here, if I show you this log and I want you to rewrite it as an exponential, all you have to do is say, okay, here's my base. There, it's to that exponent, and it equals that result. And that's how we get this. B to the x equals a. B to the x equals a. Okay? And that's how you read it. Log base b of a equals x. Okay, that's how you read the log part. Exponential is b to the x equals a. So let's try a few of these. So if we look here at number 1, we have log, if we say it in words, log base 3 of 9 is 2. What that is saying is I have a base of 3 to the second power, and the result is 9. So I rewrite it 3, there's my base, it equals 2, so that's my exponent because the log equals the exponent because log just means exponent, and the result is 9. And is that a true statement? Yeah, 3 squared equals 9. That's all this whole log. Now there's a whole bunch of stuff we're going to start talking about. There's properties, just like the properties of exponents, and all that stuff we're going to do. But basically, this is what this is all based on: exponents, exponentials rewritten as logarithms. So if we look here, 6 is my base, 3 is my exponent, 216 is my result. So 6 to the power of 3 equals 216, and that's true. 6 times 6 times 6 is 216. Okay. So if we look here on number 3, we have a base of 7. Exponent is 0 because log equals the exponent, so 0, and it equals the result of 1. And is that a true statement? 7 to the 0 power equals 1? Yes, anything to the 0 power equals 1. Questions so far? Any questions so far? So the first thing we're doing right now is we're converting a log to an exponential. We're getting a logarithmic statement, and we're changing it to an exponential. Okay, so let's try another one. Base of 2, the exponent is 4, and the result is 16. Mister, these seem really easy. Yes, they are easy because everything's numbers here. There's going to be x's and y's and all this other stuff and expressions later on that we have to figure stuff out. But for now, we just want to know, can you make a log into an exponential? And then in a minute, we're going to do exponential back to log. I want to make sure we can do this. Uh-oh, fractions. Still do the same way. Don't freak out. Here's my base. My base is 4, so I do a base of 4. It's raised to that exponent, which is -2. And the result is 1 over 16. Now, is that true? If we think about what we did a couple weeks ago or last week, 4 to the -2, remember, negative exponent just means reciprocal. So let's see if this is true. For the -2, if I flip it over, that's 1/4 squared, right? We just flip over the 4 and we take the exponent with it and it turns positive. When you reciprocal, the exponent turns positive. Is that the same thing as 1/16? Yes, it is. 1/4 squared is 1/16. Okay. Last one, 9 to the 3/2, so base of 9, and the exponent's 3/2. Remember we did this a while back. We did fractional exponents, and the result is 27. Okay. Is that true? Well, let's check. 9 to the 3/2. If you remember, that means I have 9, and this little number down here is my index, and the number on the top is what I raise it to. Is that 27? And remember, see that 3 that was on the top? I can either put it inside or on the outside, and I choose to put it on the outside because look what I have in the parentheses. I have square root of 9, which is 3, and 3 cubed is 3 cubed 27. Yes, it is. Okay. So that's changing logarithms to exponentials. If I give you a log, you should be able to change it to exponential form using this. The base of the log is the base of the exponent. The number next to the log is the result. And what the log equals to is the exponent. Log equals the exponent because log means exponent. It's just a different, logarithm is just a different name for exponent. Okay. Any questions here? All right, let's go the opposite way. So I'm going to give you an exponential. You give me the log. So if I come here, so I'm going to write log. What's the base of the log? Well, what's the base of the exponent? The base of the exponent is 14.
14.
My log. Good. And so what would I put next to the log?
Oh, 196.
Very good. And this whole log equals
2.
Good, because that log equals the exponent. And let's check it. Is this true? Is 14 to the second power equal 196? Yeah, it checks out. That easy. It's that easy. Let's try number 8. Log base
3.
81 equals 4.
Yay, there you go. It works out. 3 to the 4th equals 81. Pretty simple, right?
Yeah.
See these fractions. Let's do some of these fractions and negative ones. Like let's do 10. So we still have log. The base is 36. The result is 6. And the exponent is 1/2. Yeah, makes sense?
Yeah.
Okay, because this is where kids get thrown off when you see the fractions and the negatives. They're like, oh, what do I do? It's exactly the same thing. The base, the exponent, the result. 11, this would be log base 2 of 1/8. And a lot of times we like to put parentheses around what the result is. So, because sometimes it can get really complicated. So try to get in the habit of, and maybe I should have been doing that, putting parentheses around what you're taking the log of, because it can get a little complicated and you want to make sure you have a clear equation, and that equals -3. Now, one rule I need to tell you, you can never take the log of a negative number. This result right here will never be negative. Okay, because you'll have a positive, you always have a positive. This will never be negative either. The base will never be negative. So if you have a negative base, if you have a base to a exponent, you're never going to take the log of a negative number. So we'll see that a few times. And then lastly, the log base 8 of the result 16 equals 4/3. And that's it. That's page 1. That's converting logs to exponentials and then exponentials to logs using this definition up here. And understanding that logarithm just means exponent. When you're finding a logarithm, when I ask you to find a log, you're finding an exponent. All right, next page. You've seen log on your calculator and it doesn't have a little base on it, right? And the reason for that is there's something called a common log, the log that we use most commonly, and that's the base 10. And why we have base 10? Because we like base 10 as humans, because that's what we started with because of our 10 fingers. So log base 10 is just written as log. So if you see log base 10 of x, or you see log of x, it's the same thing. It was like an invisible 10 right here. Okay, and we like that. And so most calculators have log, and it means log base 10. And then I'll show you later on how to change any log to log base 10 so you can use a calculator if you don't have a calculator that can do other logs. Okay. All right, so now we're going to try to figure out and evaluate these logs, or figure out what the exponent is, right? When we're finding logs, we're finding exponents. When we're just given the log side and we don't know what it equals. So log base 7 of 49, we want to know what that equals. So this is basically asking, if I have a base of 7, what exponent will give me 49? Right? That's all it's asking. When you're looking for a log, you're looking for the exponent of that base. So this is asking, what base of 7, I'm sorry, what exponent of 7 will give me 49? And what's the answer? 7 to the what power is 2. Now let's check that.
Power.
This 7 to the second power equals 49. Okay. That's all you're doing. So when you're evaluating logs, you're finding the exponent. Number 14. So 3 to what power gives me 27?
To the third power.
Perfect. 3 to the third equals 27. You can check it by changing it to an exponential and seeing if it's true, and it is. Log 100. What's the base of this? What's the base
10,
of
right?
this? 10. Yeah, if you don't see one, there's an imaginary 10. So 10 to what power gives you 100?
To the second power.
Second power. So this is 2. So when I evaluate it, my answer is 2. And I can check it by saying 10 squared equals 100. Checks out. Now, what if it's not so obvious? Those 3 were pretty obvious. 7 squared is 49, 3 cubed is 27. What if it's not so obvious? Well, if it's not so obvious, this is what you do. You say equals, and you put an x. Say, I don't know what it is, so it's x. And then you change it to an exponential. So now let's change it to exponential. So base, exponent, result. 12 to the x equals 1. What gives me a 1 if I have an exponent every time?
Would it be a
We
0?
talked about this earlier. Yes. X would have to equal 0. Or this whole log equals 0. Because anything to the 0 power is 1. Okay, always remember that. You're going to see that a lot. Anything to the 0 power is 1. All right, let's go to a difficult one. Let's see. I like this one, 19. So 9 is my base. I want to know what exponent will give me 1 over 81. Not very clear to me in my head, so I'm going to say, okay, I don't know what it equals, so it equals x. That equals I don't know. And then I'll change it, base, exponent, result, base, exponent, result. And now it becomes one of those problems we did a couple weeks ago when we were solving exponentials, right? What do we do here? Well, what do we do? You guys remember? Remember we had to get the same base on both sides? And then once we have the same base, we drop the bases and focus on the exponents. So if I look here, this is 9 to the x, and 81, isn't that 9 squared?
So does that mean that x would be 9 squared? 99 squared or 9 negative squared?
No, well, we're not there yet, but you're on the right track by saying negative, because you see how the 9's a fraction? We don't want the 9 as a fraction. We want a whole number 9. So I'm going to flip it. I'm going to flip, oops, I'm going to flip this side. And so when I flip it, the exponent turns negative. So this becomes 9 to the x equals 9 to the negative 2, right? If I flip it. And then now I have the base is the same. I can say the base is the same, then the exponents have to be the same. So what is that? Negative 2.
equals
Negative
-1.
2.
Yeah, which makes sense because if I put -2 here, that's saying 9 to the -2 equals 1/81. Which is true because -2 means I reciprocal it, which would make it 1/9 squared, which is 1/81, which is true. Okay, so you might have to look back at those notes to remember how to solve these. So once you set up your equation to figure out what this log is, you may have to go back to your notes and say, oh, wait, how do you solve an exponential of 9 to the x equals 1/81? Get the same base. Once the bases are the same, then you set the exponents equal to the same thing. And if we come here, number 20, 64 to what power gives me 4? I don't know. So I'm going to set equals, I don't know, or equals x. 64 is my base, x is my exponent, 4 is my result. 64 to the x power equals 4. So now, in order to solve this, I need to get the same base. They aren't the same base right now, but if I think of 64, do you remember if 64 is 4 to a power? What's 4 times 4 is 16, and 16 times 4 is 64. So that's 64.
Oh, wouldn't it be 1/3?
It's 4 to the third, right? Yeah, exactly. So this would be 4 to the third. Then we still have the x. Now we have the same base. So this is 4 to the 3x equals 4. And if there's no exponent there, it's to the first. I have the same base. So if I have the same base, I can just say the exponents are equal. Divide by 3, divide by 3. And there you go. You're right. X equals 1/3. Okay, so if you forgot how to solve these kind of equations, go back to your notes from a couple weeks ago and the video from a couple weeks ago. But in order to evaluate these, if you don't know what it is, set it equal to x, change it to an exponential, solve the exponential. Okay, I'm going to show you one last thing so you can use your calculator for any of these logs. So some calculators let you put any base you want, like log base 7, log base 10, I'm sorry, log base 12. But there's some calculators that only have log base 10. So let me show you. We have a change of base formula. Okay, and what this says is if I have a log with any base b and the result is a, I can change it to log base 10 of whatever that a is over log base 10 of whatever that b is. And then I can put that into my calculator and get a result. Let me show you what I mean. Log base 16 of 64. So let's say I have a calculator. I'm like, I can't put 16 for my base. No problem. I'm going to put log base 10 of the a of the 64 on top, log base 10 of the old base on the bottom. And then if I punch that into my calculator, where did my calculator go? Well, if I punch that into my calculator, log of 64 divided by log base 10 of 16. You guys have a calculator there or no?
I put it in. I do, but I think I put it in wrong.
Did you get 1.5?
No, I got 1.7. But I put it wrong. I forgot to end the parentheses on the log, so I put them like together.
Oh, right. A lot of times you have to end that parentheses.
Yeah. By log 16. Yeah, 1.5.
Yeah. All right. Good. Okay. Now, if you don't want to, like, you say, Mister, I already have so much in my head right now. I don't want to do change of base. My calculator does all those other bases. That's fine. Then you're good. If you have a fancy calculator that does that, that's great. But there might be a time you don't have a calculator that's fancy, and then really quick you could just say, ooh, number 25. I'll put log base 10 of 136 over log base 10 of 4. Punch that in. You'll get the same answer. All right, guys, that's pretty much it. If you have any questions, let me know right now. I can answer them. Anything confuse you? They go too fast? They want to talk about
Mister,
something else? Yeah.
for the log A, log B, what's the small text that you put? Is that just like 16 on the 64? Or 10? Oh, it's 10.
Yeah, it's a log base 10. Yeah, because that's what the change of base is. Where change of base is changing it to base 10, because that's what calculators
Okay.
have. Yeah. I'm sorry. Yeah, my writing is still sloppy. How are you guys doing? You guys good?
Yeah.
Hanging in there.
Yeah, hanging in there. Yeah, that's what we're all trying to do, right? Hang in there.
Yeah.
Mm-hmm.
All right. If you don't have any questions, guys, that's pretty much it. If you come up with another question later, you can send on remind. Just let me know. And, the quiz will be up tomorrow. It'll be due by Sunday. But again, if you need more time, go ahead and take a little more time. I won't take off points. Just let me know.